What an honor it is for me to be here today. This is my first ARC forum that I've ever attended, and a lot of the topics are really interesting to me. I've been with Solvay Chemicals for 26 years. I am the process control foreman there. If you will, travel with me from snowy and cold Orlando to western Wyoming, about 8,000 feet higher than we are right now, and it's sunny and warm there, I guarantee it, at 26 degrees. So travel with me there, and we'll go through some things. I got a few slides on what we do, if you'll bear with me, and then I'll get into the meat of what I want to talk about. But I work for Solvay. A branch of that is Solvay Chemicals. Solvay created in 1863. Solvay is a global company driven by proud and committed chemists. With our historical anchorage in Europe, our products serve diversified markets worldwide, from consumer goods to energy, with one main aim to improve the quality of life and customer performance. We do a lot of specialty chemicals, and maybe a lot of you have heard about us. Solvay is comprised of 169 sites in 52 countries, and we have over 30,000 employees. We just recently acquired Cytec. That's been in the news lately. Solvay is the world's #1 producer of soda ash and sodium bicarbonate. Soda ash is used mainly in the glass and in detergent industries. Sodium bicarbonate serves primarily the food and feed markets and the health sector, and also used to neutralize acid flue gases. The Solvay Chemicals Green River site where I work produces soda ash, sodium bicarbonate, sodium sulfite, and Trona products, which is beneficiated mine run ore. The Green River site employs, around 450 people. So this is our site in Green River. This is the refinery site, sits on 150 acres. Our leased mine is about 40,000 acres. Most of our products move to market via railroad. You'll see right there. Our mine is 1,600 feet below the refinery, and it's classified as a hard rock gassy mine by the Mine Safety and Health Administration. What we mine there is Trona, and Trona is ore that contains sodium sesquicarbonate. It's relatively rare sodium-rich material found in the United States, Africa, China, Turkey, and Mexico. In the Green River area, we have 80% of the world's known Trona reserves, at about 100 billion tons of Trona. 60% of that is mineable by conventional methods. The methods we use to mine it are solution mining, a little bit of solution mining. We also do partial pillar mining, and we also do longwall mining. This is a picture of our longwall, 625 feet long, and it mines a seam of 1.5 miles before it's moved to its next location. That ore that we bring up to the surface, we crush it and we calcine it. We leach it down into a slurry where we can filter it and get the impurities out of it. Jumped a little bit there. That clear, clean liquor, we call it clear liquor, is put into crystallizers or evaporators, where we boil the water off. It reforms crystals. The crystals are then centrifuged and dried and sent to our silos. You'll see the picture on the bottom right there. That's before and after. So that's our finished product in the actual Trona that comes from underground. Let's talk about our refinery control system. In 1998, we had a migration from Honeywell TDC 3000 to Yokogawa CS 3000 system. Our first probably control system was put in 1990. So we had a major plant expansion where we added about another third onto our plant, and that's when we went to the Yokogawa CS 3000 system. Most recently, we did the 2014 upgrade to Yokogawa Senem VPR5. And that's what I'm talking about today. Our control system resources, we have over 8,000 individually hardwired I/O coming into our control system. We have over 3,000 communication I/O points coming from SCADA systems, process safety management systems, and different PLCs around the plant. We have 21 field control units in 2 different domains. We We have 17 operator workstations. We have 6 engineering workstations and 8 plant application servers. Our control system runs processes up to 20 miles apart. So we had to come up with a justification for our upgrade. Probably the biggest thing we had was in 2012 we found out that Windows was no longer going to, XP was no longer going to be supported. We had a lot of communications between different plants and different companies, people that do what I do for our different plants that have the same control system, and we were trying to decide who was going to do it first, and I guess I just decided we were going to do it. I kind of hoped somebody else would do it first so we get the history, but we decided we'd go ahead and do it. The cost and availability of XP computers went up exponentially for me for my control system. They went up 3 times what I could find in 2013 when they announced this. So I was having a hard time finding hardware. The hardware that we had on the PC side was dated. It was 7+ years old. We tried to change out our PCs at about 5 years, but we were kind of hanging out. We heard that this was going to happen, and so we tried to get as much runtime as we could out of them. We were experiencing lots of hardware failures on our computer side of things. You'll see under this desk right here, we had our operator stations, computers underneath the operator's desk. Hot, dusty environment. You can see there's actually some buildup on that computer. You can see on the screen on the front of that computer. We were losing lots of power supplies and lots of video cards and computers themselves. Another thing we wanted to do was align our system security with our corporate standards. We had recently got a document from our corporation on what good control system security was, and we were nowhere near where we needed to be. So we wanted to take advantage of that. Our plant was coming up on a 5-year total plant power outage. When you run 365, 24/7, the power doesn't go out very often. The process that we run crystallizes back up rather quickly, so everything needs to be cleaned out, washed out, and drained, and we don't do that very often. And in today's business world, it seems like we don't do the total power outages only when it's absolutely necessary. We'll run 2/3 of our plant and take 1 train down, and then in the fall when we do a fall turnaround, we take another part of our plant down. So we were coming up on this. And the reason for that is we wanted to do upgrades to our field control stations and do offline downloads. And to do that, when you do that, the process has to be off. Another thing that our plant adopted was, I think every plant probably has some kind of initiative going on. Solvay's is called World-Class Factory. We adopted this from the corporate level, and basically what World-Class Factory means is that every part of our business is world-class, and that's what we strive for. So we were feeling in the control side of things that we were lacking. We weren't absolutely world-class, and so we really wanted to try to get there. So we had some challenges. Challenge number 1, and probably a lot of you know this, is procurement timing. We knew we were going to do this 2 years ahead of time. We knew that we were going to do it, and then we needed to save some money to do it. But the way money works sometimes, especially in our case, our outage that we were going to take was the last week in April and the first week of May. We didn't know we had the money until the first week of February. So to pull the plug and do this till the first week of February. And that put us past our solution provider standard lead time of about 8 weeks, and that would put us past our shutdown. So that was really hard for us. And also, to implement some of these world-class factory things that we were doing, we wanted to have time to install new infrastructure. We needed to put conduit runs and fiber optic cables and new cabinets and power supplies and define clean rooms to put all this stuff in. So it takes some time. So that was quite a challenge. Challenge number 2 is just working in a plant that's offline. Like I said, with our offline loads to our controllers, the whole plant has to be down. The last time we did offline downloads to our controllers was in 1998 when we installed it, and that's pretty unheard of. It's really a neat thing we could go that long. We had several computer upgrades, platform upgrades, and still could run on those original offline downloads. So we wanted to take advantage of that. We knew there were some more features out there that we could probably get by doing that, so we wanted to take advantage of that. And because of the power outage, we had to have generators up for 12 hours to do the offline downloads. We have a UPS system that could probably last for 8 hours, but we wanted to have good power, so we had generators running for 12 hours so we could do the work. But that meant we had to squeeze everything into that 12 hours that we needed to do. The power outage, was, like I said, was scheduled for 12 hours, so we had very limited time to do what we needed to do. That was quite a challenge. Challenge number 3, our plant controllers. When doing offline download, the way our plant is configured, when you do an offline download, it puts all the control blocks into manual. If I have any SFC programs running in the background or anything, it stops those. And all those would need to be put back in the correct mode before the plant was able to come back online. So that was a challenge that we had to think about. And number 4, anytime you do an implementation or a rollout of a new application, you got to ask yourself some questions. And we asked ourselves, how do we roll this out on a running plant? Sure, we had 12 hours to do the offline downloads, but how are we going to roll out the rest of the application to the whole plant while it's coming up or it is running? How do we train the operators? Anytime you have a revision upgrade, what are we going to do to train the operators so that they're comfortable with the new systems that we put in? With this one, we were going to get a new graphics style. We had the old square graphics, and we were going to a nice new widescreen graphic. Plus, anytime you have an upgrade like that, you have all new bells and whistles for the operator interface, which makes things a lot better for them, but they needed to get used to that. The other thing is, how do we change out all the operation stations and the servers as quickly as possible, and without any disruption? So, coming up to solutions to the challenges, the solution to the financing is communication, right? We've talked about it in other sessions of this conference, and communication's the key. I communicated with our people for capital projects. I communicated to different departments. I got them all on board with what needed to happen. They were able to let me borrow some money from their budgets to put in the hardware that I needed. And then I was able to back charge that money back from our project once it got approved. We were pretty sure it was going to be approved, so we kind of went for a little risk there, but we borrowed some money from other people to do it. And also, our solution provider worked with us really well to get the computers we needed on time. Like I said, they had normal standard turnaround times 8 weeks, 6 to 8 weeks. And they worked really well with us to solve that problem that we had. Challenge number 2, having the plant offline because of the short time window. We spent months concentrating our efforts on defining what needed to be done before, what needed to be done during the 12 hours, and what could be done afterwards. And we defined some Gantt charts to lay out all those jobs that needed to be done and get all those done ahead of time. Like I said, with all the conduit runs, the server cabinets, we were actually changing the structure of our control system. So solution 3 on the plant controllers, that was quite a challenge to get everything back up so the plant could run. So what we did before we did an offline download, there's a report package in our control system we ran. It told us what the modes of every block were. So we ran that, we did the offline download, we re-ran that report, and then we compared the 2 reports in Excel to tell us what blocks were in different modes. And it actually highlighted those blocks and told us which blocks needed to be changed. So then we spent a couple hours going through the controllers, getting them all right back into the right mode. And this is all in that 12-hour window. So we would do one, had 2 guys go back through after we did the offline downloads and get all those modes in, and then we just worked through all the controllers that we had to get them all done. It worked out really well. So we ran that report. It was able to tell us what we needed to do. We got them all put back in the correct mode for plant startup when the power came back up. Solution number 4 on the implementation part. Prior to doing anything, we were able to get with Yokogawa, and they had a tool that took our file of over 350 graphics and run it through this tool that would convert it to this new widescreen format. And all we had to do was quickly go through it and just make sure everything looked okay and worked okay. And that saved us months and months of configuration. I don't know how long it takes you people to build graphics, but we didn't have to go and rebuild all the graphics because of that tool, and it just made things a lot better. And then for part of the implementation, each of our control room operators has 2 stations. And so what we chose to do, they're pretty experienced operators. They've been through some migrations and upgrades and things before. But what we did is take 1 station down at a time. We put the brand new station up and got it running, which was another credit to our provider, that you can run both versions at the same time while you're cutting this over. And that was, I didn't know that was going to happen, but how great that was to be able to do that. So we had so many machines to change out that we went around and changed 1 for each operator, had a shift change in the middle, so got new operators back in. That gave them the opportunity to look at the old system and the new system together. If they had any questions, they could just go back and forth between the 2 and then use us as a final resource if they needed it. But then we came back around 2 or 3 days later and changed those other machines out, and we were all up and running. So that helped. So benefits or performance metrics on this, you know, the hard benefits are really hard to define. We had a control system that was great before. We hadn't had a single failure on the control system side of things since 1998. So it's not like saying we're going to save a bunch of money by doing this or make a bunch of money by doing this, but there's a lot of soft benefits to be realized. You know, the one thing for us was better system security. Before, the operators could take a jump drive and just go like this into the computer if they wanted to. You know, they knew their job was at stake if they did. Nobody had done it, which thankfully they hadn't. But they could always stick a jump drive in there. And so what we did by doing this, we put KVM extenders to their desk. All the computers are down in a secure cabinet in a clean room that's climate controlled. So it gets it away from that opportunity for them to do something that they probably shouldn't. And through that, we get better serviceability with, you know, of the equipment with rack-mounted machines away from the operators. We're not crawling under their feet every time we need to change out a video board or change out a computer, you know, which is a disruption to them. Also, our equipment, like I said, is in a cleaner environment, and there's a lot less failures. And then with any upgrade, you get the latest and greatest system options for the operator interface. Takes a little bit for operators to get used to. They're resistant to change, but when they find out these neat new features that they have, we went from the graphics are all tabular now, so they can have 5, 6, 7, 8 graphics up at once, and just with tabs, and they can go back and forth between them, and they really like that. That's just one of the many benefits from the new system. And then for us on the you know, configuration side, we have new builder function tools loaded with the new templates and the field controllers. We have more options, more control blocks, better functions that we had in 1998 when we put it in. And it's a great upgrade for us. Plus, you know, on the software side, we're keeping up with the migration path to the future with the control system. We want to make sure that we keep up, be a partnership with our supplier, and keep on that path that we need to be, so we can provide the best value for our company. And who doesn't like new equipment? You know, I mean, we got all new computers, kind of like take some of the heat off once they get burned in and everything works good. So we're enjoying the benefits of that still, you know, a year and a half later. Operators wanted me to put this in, my guys. They said, this is our control room before. This wasn't our control room before, but they really liked that picture. So some of the lessons that we learned, you know, you definitely need to understand your solution provider's migration path for the future. You need to be a partner with them and talk to them and sit down with them and understand their migration path, and give them your input about your migration path. Definitely communicate with them on that. Also, the importance of vendors backwards compatibility through new innovation. It's wonderful when you can have a control system that can have 1975 technology that works, you know, in 2017 or 2016. You know, it's a great opportunity to be able to do that. Also, I guess one of the biggest things we learned on this was communication. Communication with our vendor, communication with our upper levels of management to be able to handle this. And also, we need to expose ourselves to best practices and be aware of the latest in innovation. And that's why we're at this ARC forum. That's why we go to our users conferences, is to be aware of the latest in innovation, the latest offerings that our suppliers have for us. And stay ahead of the ball. And when I say stay ahead of the ball, that means with this project especially, when we had all this work that needed to be done up front, on the front end, we didn't waste any time. We knew what we had to do. We didn't sit on our laurels and wait until the control system manufacturer showed up to help us do this. We did everything we could to get it done so that when we came, we had the 12 hours with them to take care of this. Our engineer that showed up to help us, we had, I'll tell you, resource-wise, there's 4 guys in my group and myself, and they're DCS technicians and me. And then we had 1 engineer from Yokogawa and one maintenance service tech help us do this revision. And the engineer that helped us, he said this is the very, very best one that I've ever seen done. And it's because we did all the work up front. You know, we spent the time. We didn't sit around and wait. Hope it would get done. We tried to identify what we needed, and that helps limit, you know, the oh my goodness, we got to get this done because something's showing up that you didn't expect. So, so that's a testament to us. We're real proud of it. We're real proud of what we did. We tried really, really hard. It takes a lot of time to spec equipment out and get things installed, but that's where we're at. Thank you.